Welcome to the world of Power BI, where we're delving into context transition. This feature is all about how raw data gets shaped into filter context. Let's take a deep dive together. Imagine you're working with a customer table and want to calculate the total sales amount for each customer. To do this, you create a new column, Total Sales by Customer, using the sum function. In our effort to calculate total sales for each customer, the initial output returns the exact sales amount for every customer. Now, what exactly constitutes this sales figure? It essentially encapsulates the sum of the total sales column in our sales table. However, the most problematic aspect is the fact that, without filter context, each customer doesn't automatically filter sales data. This is where the calculate function comes to the assist. Wrapping our calculation inside calculate bridges this gap, providing the total sales amount by customer. Utilizing a measure, like total sales, offers an alternate method for precision. These measures inherently ensure accuracy by encapsulating expressions within a calculated framework. Leveraging such measures provides the precise figures needed without added complexity. Shifting gears to averaging, we encounter a puzzling scenario. When aiming for the average sales by customer, a simple average function doesn't quite cut it. Why? Since these averages represent sales transaction amounts, indicating a level of detail based on transactions rather than customers. This distinction results in lower values due to the transaction-focused granularity in the sales table. Enter the AverageX function. This function enables iteration over the customer table, row by row, calculating total sales and then averaging these values. But hold up, we're not quite there yet. Filter context issues arise, causing the measure to return figures identical to total sales. Why? We encounter two issues here. Firstly, there's a filter on the customer name, not present in the original customer table. Secondly, without forcing context transition, our iteration on the customer table gets constrained by this filter, leading to calculations based on only one row, resulting in identical figures in both scenarios. So, how can we solve this? First, we have to remove the filter context on the customer table, which we can do with all function. As a result, it returns all the rows in the custom table, and then calculate function steps in again to wiping out filter context and enabling an accurate average of total sales by customer. We obtain the average sales per customer by removing the specific filter context. Using the all function, we access the complete customer table, calculate individual sales totals row by row, and then average these values. This method applies uniformly, removing the filter context for each customer and allowing for a comparison between their total sales and average sales at the customer level. In the next part, we explore when to use a measure versus a calculated column. When to choose a calculated column? Well, it's perfect for creating categorical breakdowns or specific filters. For instance, let's create a column categorizing customers as big or small spenders based on their total sales. This new column allows us to easily filter and visualize the data, like with a slicer for quick segmentation. Moreover, in visualizations like column charts, calculated columns enable detailed breakdowns that might not be achievable using other methods. Calculated columns shine in these scenarios where you need to define clear categories or breakdowns in your data. Now, let's delve into when a measure becomes imperative. When dealing with proportional amounts or percentages, using a measure is crucial. Let's highlight the challenges that arise when a measure doesn't work, using a practical example. Suppose we're working within the sales table and intend to express the cost as a percentage of sales. One approach might involve adding a new column, cost percentage of sales, calculating each row's cost to sales ratio. Here we can simply divide the cost amount by the sales amount. This might seem reasonable at first, but visualizing this on a matrix shows surprisingly high values. The reason? Each percentage is calculated independently per transaction and then summed up for each customer, leading to an incorrect aggregation. Attempting to rectify this by averaging these values still falls short. Averaging neglects the inherent weight each transaction should carry, resulting in inaccuracies. To demonstrate, consider two transactions with distinct cost and sales amounts. Computing their averages would yield misleading results. What's essential here is obtaining a weighted average, accounting for the varying transaction magnitudes. To achieve this precision, a measure comes into play. By crafting a measure, let's name it cost of sales and percentage. We can sum up the costs and divide this sum by the total sales. This process delivers accurate proportional amounts that account for the varying transaction sizes. Such nuanced calculations that account for proportional values are a forte of measures, and this is a scenario where calculated columns fall short. In essence, using measures for proportional values ensures accuracy, reducing unnecessary data clutter in models. While both measures and calculated columns have their uses, measures shine in nuanced calculations, essential for mastering DAX functions and streamlining data analysis. Now, let's put these concepts into action. For instance, let's calculate the percent of total sales. To achieve this, I'll create a measure called sales percentage of total. First, we'll need both the total sales for each customer and the overall sales of all customers. To do this, I'll create a variable called sales all customers using the calculate function. This function helps remove filters, in this case, on customer names. Once we've confirmed that sales all customers returns the totals we need, the next step is simple. We'll create another variable for sales percentage of total, which divides the total sales by the sales of all customers. With these variables set up, we return the final result, providing us with the desired percentages. This is just a quick demonstration of the key concepts in action. Mastering these detailed calculations with measures is the key to unlocking the full potential of your data analysis in Power BI. If you have any questions or need clarification, drop them in the comments below. Thanks for tuning in, and don't forget to subscribe and like. I'll see you in the next video.